Hello, chemistry students. Today we are going to do gas stoichiometry lab. So let's have a little background before we start our lab. You have just been hired as an intern at Chemist RW2 Institute, a chemist consulting company. Chemist RW2 was contacted by a hair salon that uses hydrogen peroxide as a part of their hair dyeing process. Their new shipment of hydrogen peroxide does not seem to be working as well as normal. Hydrogen peroxide is typically sold as a solution of H2O2, a liquid dissolved in water. The label on the bottle all says 6% hydrogen peroxide, but the hair salon suspects the concentration is not this high. Your supervisor at Chemist RW2 has handed the project over to you along with the sample of their hair salon. Your goal in this experiment is to determine the mass percent of hydrogen peroxide in this sample of hydrogen peroxide and to compare it to the label value, which is the 6%. The formula that we will be using to find the mass percent is given here. And what happened at the reaction level? Hydrogen peroxide decomposes slowly over time into oxygen gas and water. So this is the reaction for hydrogen peroxide decomposition. On its own, the reaction is very slow to observe, but it will occur quickly if a catalyst is added. Baker's yeast contains an enzyme called catalase, and this catalase enzyme works as a catalyst in this reaction. Catalysts are the species that can speed up the reaction. So this reaction naturally occurring is very slow to observe, but if you add yeast, you can complete this reaction in few minutes. Because a gas will form in this reaction, you can use what you have learned about gases and stoichiometry in your ideal gas chapter. You will do this by measuring the volume, temperature, and pressure of oxygen gas that forms. The ideal gas law can be used to determine the moles of oxygen gas that formed, and stoichiometry can be used to convert the moles of oxygen gas to the grams of H2O2. We did this practice in the lecture. By comparing this mass, the original mass of hydrogen peroxide solution, you will able to determine a mass percent. So this is the setup for the experiment.
Okay, Shahyan is going to help us demonstrate gas stoichiometry lab. Let's see equipment and supplies needed for this lab. We need a digital scale, 250 Erlenmeyer flask, one hole stopper with tubing connector and 2 feet flexible tubing, 100 ml graduated cylinder, 10 ml graduated cylinder, large plastic container, one medium plastic cup, thermometer, plastic pipette, rubber band, hydrogen peroxide, yeast, spoon, tap water, and a cell phone to look up local air pressure. Okay, the first step for this lab is we have to activate yeast, and for this you need 40 ml of warm water at about 45 degrees Celsius. So we have 45 degrees Celsius or around 40 to 45 degrees Celsius water in this cup. Next, Shahyan is going to add yeast in this warm water and stir it with a plastic spoon. Okay, then you can keep this to the side and we will set up the rest of the experiment. Next, you need large plastic container filled with about 2/3 room temperature tap water. You need 100 ml graduated cylinder filled with water up to the brim. Next step is we have to invert this graduated cylinder into the container and make sure that no water is spilled. In order to do that, you can either put your hand at the top or you can do the same thing as Shahyan is doing right now. So he's going to put a plastic cling at the top and then he's going to wrap it around. So we have to just make sure that no water spill, because if there's water spill, then there will be room for air and we do not want any air trapped in this cylinder. So now Shahyan, go ahead and carefully invert this cylinder inside the water. Keep the cylinder inside and carefully remove the plastic cling. Leave the cylinder inside. Okay, you can move the container on the side and we can move to the next step. Just make sure the cylinder stays inside the container. Your flexible tubing should be connected to a plastic tubing connector. And the tubing connector should be inserted into the hole of the rubber stopper. These connections should be snug so that no oxygen gas can leak out. The free end of the flexible tubing should be in U shape. You can use a rubber band to hold it in this shape. Insert the U-shape end of the flexible tubing into the plastic container. Carefully maneuver the end of the tube into the opening of the graduated cylinder, and you have to make sure that about 2 inches of the tubing is inside the cylinder. And be careful, the cylinder should not come outside the water. Okay, you can see this, the 2 inches of the flexible tubing is inside the graduated cylinder. Next, we are going to take the mass of 5 ml hydrogen peroxide. For this, you need 10 ml graduated cylinder. And in this 10 ml graduated cylinder, Shahyan already have transferred 5 ml of hydrogen peroxide. Okay. Okay. Turn on your scale. Make sure it is tare and it is reading 0.00 gram. After that, you place your clean dry Erlenmeyer flask on your digital scale and hit tare button again. Pick up the Erlenmeyer flask and pour 5 ml hydrogen peroxide into it. Place the Erlenmeyer flask back on the scale and record the exact mass of the hydrogen peroxide solution in your report form. Place the rubber stopper on top of the Erlenmeyer flask and keep it aside. Next, we are going to take initial volume of air in cylinder. To do that, Shahyan, hold the cylinder vertical, straight, and see if there is any air volume in the cylinder. And you guys can see that there is actually no air in this. So if no air, then Shahyan, go ahead and write down the reading as 0.00. Sorry, from 100 ml cylinder, it will be 0.0 ml. Okay, Shahyan already have 5 ml of yeast solution in 10 ml cylinder. And now Shahyan, go ahead, remove the stopper from Erlenmeyer flask, but keep it in your hand. Your next step is going to be very quick. So pour 5 ml yeast solution into the Erlenmeyer flask and quickly cap. Okay. You should immediately see some gas bubbles coming into the cylinder, and you can stir this solution. Yep, stir it. Okay, so you should see the gas bubbles coming in the cylinder, and you can see, Shahan, if you hold the cylinder vertical, you can leave this Erlenmeyer flask on the floor. Okay. If you keep it vertical, now you can see that there is air, right? And that air is the oxygen gas coming. And if you look at the tubing at the bottom, it's just difficult to zoom in. But if you look at the tubing, you can see the oxygen gas bubbles coming out. If you don't see this gas coming out, it means there is some leak somewhere in your rubber tubing. So check that rubber stopper if that is tight. Swirl the Erlenmeyer flask and let the reaction run until the volume of gas in 100 ml graduated cylinder stops changing. This may take up to 5 minutes. Place your thermometer in the container of the water and record the temperature in degrees Celsius. We are assuming that the temperature of gas in the cylinder is the same as the temperature of the water.
Let's see how to do the calculation for gas stoichiometry. Mass of hydrogen peroxide, you will record this reading from the scale. Initial volume of air in the cylinder, this reading you will take from the cylinder. You will be taking it with 1 decimal place, and this is the reading that you will take right before adding yeast to the Erlenmeyer flask. Final volume of gas in the cylinder, this reading as well, you will be taking it with 1 decimal place, but this will be after like 5 or little bit more minutes when you see that the volume of gas stops changing. Next, you have to find volume of oxygen gas that has collected. That will be the difference of these two readings. You will get that difference in milliliter, and then you will convert that milliliter to liter. The temperature is the temperature of water that we took. Make sure you record this temperature with 1 decimal place, and then you convert that Celsius temperature to Kelvin. Barometric pressure, you need your computer or cell phone to look up the barometric pressure at the time of the experiment. So I checked the barometric pressure when I performed the experiment, and it is 29.95 inches of mercury. This number will be different for everyone. So you will be taking the barometric pressure at your location and at the time when you are performing this experiment. Whatever inches of mercury barometric pressure you have, you will be converting it to ATM. Inches, remember we have a conversion factor that 1 inch equals 2.54 centimeter. You will be using that conversion factor to convert inches to centimeter, and then from centimeter you are going to convert it to millimeter of mercury, and from there you will convert it to ATM. So once you have all these right units that you need, you will be rearranging your ideal gas equation to solve number of moles. And after that, you will plug in these values, like pressure will be in atmosphere, volume will be in liter, temperature will be in Kelvin, and R have a constant value. So you will be using that. Once you have moles of oxygen, next step you need to convert the moles of oxygen to mass of H2O2. In order to find the mass of H2O2, first you need moles of hydrogen peroxide. To get the moles, we need to do mole to mole conversion, and that you can do from this balanced equation. So we have 1 mole of oxygen for every 2 moles of hydrogen peroxide. So you will be using mole ratio conversion here to convert moles of oxygen to moles of hydrogen peroxide. And once you have moles of hydrogen peroxide, you will be converting those moles to the mass of hydrogen peroxide with the help of molar mass conversion factor. And for all these steric measurements, you actually have to show the calculation on the calculation page here. Okay, so make sure you show those calculations there. And once you have the mass of hydrogen peroxide, the next step is you can find mass percent of H2O2 in original solution. To find mass percent of H2O2 in original solution, you need mass of hydrogen peroxide that you will get from here. You will divide that by mass of hydrogen peroxide solution that you have here and multiply it by 100. That will give you the mass percent of H2O2 in original solution. Once you have mass percent of hydrogen peroxide here, You will reread the original scenario at the beginning of this lab, and based on your result and calculation, you have to tell the hair salon about their new shipment of hydrogen peroxide.